instruction from RAM and the data also from RAM. So this thing will be maintained by the operating system, how the data will be captured and from which location you are capturing data from of the RAM, and how the CPU is actually taking data to execute that one. The device drivers for RAM chips are included with the operating system. That means device driver means, I have already told that for every IO device you need a device driver. That device driver is working with the RAM chip that is included in the operating system. That means that it is actually the operating system knows the device driver. When the device is working, suppose printer is working, scanner is working, so the operating system knows the device driver and it will communicate with the device driver to control its operation. Okay. See that one problem. If RAM needs an operating system to work and an operating system needs RAM in order to work, how does the computer activate its RAM to load the operating system? So first of all, one thing is there, RAM needs operating system to work, they are telling. Okay. But see that initially when you are going to load the computer or you are going to boot the computer, operating system itself comes in the RAM and it is getting installed in the RAM. Okay. So when it is getting when it gets worked, at that time some other application can come and they can run. Suppose you are going to turn on your computer and then you want to listen some music. So first of all you have to open Windows and Windows will be loaded in the RAM. Then you have to open music player, like your any player is there, suppose KM player is there. So KM player will be loaded in the RAM and that will start running, start the songs. Okay. In this way some applications will be running. Operating system mode is there. You can see that there are two different mode. One is the user mode and the other one is the kernel mode. So user mode means that in the user mode the user application programs will be there, and in the kernel mode the kernel means the heart of the operating system. So the kernel actually is a server, you can say, and the user is the client here. User has different services, different application programs to work with, and the kernel has the scheduler, memory manager, IO device manager, file system, security system, graphics system, etc. And the dispatcher is there. Dispatcher is a program that is like a scheduler. Okay. So dispatcher will dispatch the different applications from the user to the kernel. Okay. And in the kernel side, suppose the kernel is taking the responsibility that what type of application is there, if it is okay. Suppose the application is a memory management required application, then it is some different thing. It is process scheduling type application, then it is some different thing, and accordingly the kernel will communicate with the computer hardware. So in the operating system mode there are two different mode. You have to understand that one is the user mode and the other one is the kernel mode. Kernel is the core of the operating system and user is the person who is outside the who is outside the operating system. Means that as I have told you that from user to the application, then application to the operating system, then operating system to the computer hardware. In this way there is a hierarchy. The same thing happening here. When the user is trying to communicate, it has to go through the application interface, because the application interface actually is the application program by which the user is communicating. Then in the kernel side there is dispatcher. This dispatcher will dispatch the application and it will send in the kernel side, and from the kernel side it is going to the computer hardware like your hard disk, RAM, or CPU, etc. Okay, IO devices, etc. So you can see that the explanation is there. It is written. I will give you the slide in the group. You can study from here how the user mode and the kernel mode works. That I will give. Yes, one thing is there, system call. System call I have told. The system call are used to change mode from user to kernel. Okay, you can change the mode from user to kernel by using system call. there are different types of system call. One is the fork. Fork system call is created for creating one child process, and one system call is there, that is the kill. Kill system call is there to kill or destroy a process. Okay, that I have taught in the theory class. You know that one. Kernel, what is kernel? Kernel is a software code that reside in the central core of the operating system. As in the human body, heart is the core of the human body. Same thing for the operating system, the central core of the operating system is the kernel, and it has complete control over the system. The kernel has the complete control over the system. When the operating system boots, means when the operating system started, kernel is the first part of the operating system to load in the main memory. That means when the operating system is getting loaded in the RAM, then first of all the kernel, which is the first part that will be installed in the RAM. Kernel remains in the main memory for the entire duration of the computer session. The kernel code is usually loaded in to protected in the protected area of the main memory. That means that, see that in the kernel, so kernel code should be present in the main memory for the entire duration. When the computer is turned on there, till that duration, the kernel code will be installed, or the kernel code will be staying there, and it is loaded to protect in the protected area of the main memory. Okay. Kernel performs its task like executing processes and handling interrupt in kernel space. So what is interrupt here? Interrupt means that suppose the CPU is actually working normally to execute different tasks. Still, someone is actually giving some other instruction. Suppose like your DMA operation, direct memory access operation. DMA is an operation that is performed by the computer user to directly access memory without the help of the CPU. At that time, the CPU has to relinquish its operation by stopping the buses. Okay, so it will just stop the operation and relinquish the buses, and it will inform the DMA controller that it has stopped its operation. Then only can the DMA controller can perform the DMA operation, that is the direct memory access operation. So this is one type of interrupt, we can say. Interrupt means that stopping a computer or the CPU for some time for a particular task to be performed. Like suppose you are running a program in C programming and you are asked to give a input over there. So when you are and you suppose left for some time, you have went outside your room. Okay, when you will come back, you will give the input there, then only the CPU will again start your program to be executed, and during that time it will be idle. So that is the interrupt. So that interrupt happens because of what? Because the process went to the waiting state from the running state, and it is waiting for what? For a particular input to be taken, okay, from the user. The user performs its task in the user area of memory. This memory separation is made in order to prevent the user data and the kernel data from interfering with the user, and the kernel does not interact with the user directly. Okay, so kernel is not interacting with the user directly, but it interacts with the cell and other programs and the hardware. So you know about cell. I told you that bourne cell, corn cell and bash cell, these are present there. So that cell is actually interacting with the kernel, and the user is giving program through the cell, and the kernel can work accordingly. Okay, but it cannot take data directly from the user. The kernel cannot take data directly from the user. Okay, it can accept data through the cell. So kernel has different thing like scheduler. Scheduler, I told you that this scheduler schedules the processes, means how the processes will be taken. That is, there are different types of scheduler like mid-term scheduler, long-term scheduler, short-term scheduler, that were there. And I have told you that what is the job scheduler, what is the CPU scheduler, and what is the mid-term scheduler, what is the function of them. Okay, you know that one. Then the supervisor is there. Supervisor is giving permission, like suppose read permission, write permission, whether execute permission. These are given by the operating system supervisor, and the supervisor is keeping track of the different resources like your software and the hardware, whether they will be granted to perform a particular task or not. And then the interrupt handler is there, that is handling the interrupts that I have explained just now. And the memory manager is there, that memory manager is actually handling the memory locations, okay, that which particular place the user can work with, that will be given by the memory manager. The kernel provides services of different like process management, memory management, IO management, and the file management. Okay, these are the 4 different tasks performed by the operating system. System calls are used to provide these types of services. Okay, system call is explained here. What is system call? System call is the programmatic way in which a computer program or the user application request a service from the kernel of the operating system when it is executed. So that means that